He is currently working as an associate machine learning engineer at VeracityAI, and he is also an affiliated researcher at the AI team, Private Limited. He completed his research internship at MBCUAI UAE and published his research findings at a major international conference in AI. He has also won many national and international hackathons in machine learning and artificial intelligence. He is currently exploring advanced research concepts such as self-supervised learning and few-shot learning in computer vision. So without further ado, let's move on with the session. Mr. Afham, over to you.
Thank you, Owen. Thank you for the introduction, and hope you all can hear me and see my slide.
Yes, we can see.
Okay. Right. So hope you all are safe and healthy. And yeah, without further delay, we'll move on to the session. So the topic for the session is what is machine learning, and we'll be exploring some of the fundamental concepts of machine learning and how it has been changing the world right now. So the contents for this session will be we'll be talking about some of the overview of machine learning, and then a bit of conceptual machine learning, as in some of the fundamental theories behind it. But I hope I won't be boring you guys with a lot of theory. And then we'll be talking about how you can approach a machine learning project, and what are the flows you have to handle, and then what are the tools and technologies you'll be using. You have to be familiarized with when approaching a machine learning project. And also we'll be talking about the current trends, how current world is experiencing machine learning, and how the current world is making itself a better place with machine learning. So there are positive and adverse effects of AI or machine learning. We'll be talking about that. And then last, interestingly, we'll be talking about how can we get started as an undergraduate. That will be aligned with my personal experience, so that you as undergraduates can align how you can start as an undergraduate to be expert in a machine learning technology. So a disclaimer for the beginners who are in machine learning and who are interested to explore machine learning. We'll be talking about some of the new terminologies. So I kindly request you to note down those terminologies. Some of the terms we won't have much time to explore a lot. So I kindly request you to note down those terms, and you can explore them on your own. Yes, let's start with a simple question. So can machines think as humans? So I am expecting you guys to put in the chat whether it is a yes or no. It's a simple question, yes or no. What do you guys think? Can machines think as humans? Yes, I'll give around 1 minute for you guys to answer. It's a simple yes or no question. Yes, we'll start from there. You can put your answers in the chat. So yeah, you can send to me either directly, or you can send in the comment chat. Yeah, there are a couple of no's here, and there is a yes up to some extent, and there is a yes. There are lots of no. Yeah, just a couple of seconds for you guys to answer. And there is an answer, I think no, but some kind of logical algorithm. Okay, so before getting into the direct answer for that question, we'll go back a bit to the history in like around 1950s. So this is a particular question that was asked by this well-known scientist, Alan Turing. He's the founder of the Turing test. it is nothing but testing a machine's ability to exhibit intelligent behavior, which is equivalent to or indistinguishable from that of a human. So like if you pass that test, if a machine passed that test, you cannot like distinguish whether that is a human or machines. So that's able to exhibit the intelligent behavior as humans. But from this person himself, the answer to this question is no. The machines cannot think as humans, but the machines are different. So they think differently. So humans thinking pattern and machines thinking pattern are different. This is not my words, but from this person himself. This Turing test is considered one of the prominent ways, prominent introduction to the modern artificial intelligence. So his biography also has been taken in the form of a movie. If you are interested in sci-fi movies, please do watch The Imitation Game, and that will be interesting. Okay, that's a bit of a simple overview. So now, you are seeing this picture. So as humans, with your knowledge, you can see lots of objects moving around here. So for example, here is a person standing, and here is a car, and here are a couple of bicycles, and there are some shops, and there even you can identify there is a parking signs and some other road signs, and there is a, I guess it's a police vehicle, and also there are lots of buildings. So with your visual ability, with your ability to identify these objects and recognize these objects, it is pretty clear that humans are able to identify or recognize the objects at their first glance. The reason is human learning, the learning process we have went through from when we are child, has been able to make us a visual genius. Whatever we observe with our previous knowledge of seeing them or listening to them or reading them, we are able to identify what those objects are. Right, moving on. So this is one of the prominent steps taken while humans are learning, like learning from parents or even learning from teachers, learning from whatever the instance you are went through. So this particular step is what we are trying to do in machine learning. So we are trying to teach the machine as humans were learning from their children. So machines are kind of children's right now. So we are teaching the machines to learn how the children or the humans went through those learning procedures. So yes, the ultimate goal of machine learning or the artificial intelligence is to understand the whole world around us as we do. If we see an object, we recognize an object. If we read a sentence, we understand what that sentence corresponds to. So that kind of knowledge, that kind of ability, we are trying to pass to the machines. That's the ultimate goal of machine learning. Right. So what's the need of machine learning? Why do we need such a tool, such a technology to accomplish? The reason is it's kind of aligned with the advancement in the digitalization. So almost all the fields, regardless of finance, e-commerce, transportation, healthcare, agriculture, marketing, there are lots of data involved because everything is happening online. There are lots of online data, even offline data. So lots of data. The main fuel for machine learning is data. The more data you have, machines can learn easier. So because of that, data, at least in the 21st century, data is considered the new oil. If you have lots of data, you can make the machine learn better, and you can make your business better, and eventually you can make the human lives better. That's the whole idea of machine learning. Okay, so I was talking about machine learning and artificial intelligence in common. So what's the main difference? Yeah, as in the slide, we know artificial intelligence, or else AI, is the big picture. So machine learning is a part of artificial intelligence. So the whole idea is whatever the application, whatever the output you see, which can make decisions on their own, that comes under the process of artificial intelligence, that can make decisions on their own. So it can be in the business, or it can be in the research, or whatever. If a system can make decisions on their own, we can say that is an AI enabled system. And then when it comes to machine learning, that is a subset of artificial intelligence that deals with making those decisions from the previous data. Machine learning will be looking at the previous data or the previous knowledge that was going through, and then help these AI-enabled systems to make those better decisions. And there is another subset of machine learning that is called deep learning. We'll be talking about this in a little bit. So this is the big picture of AI, machine learning, and deep learning. On the other hand, we also have this particular concept, which is very trending right now. It's called data science. You also might have heard this term a lot. So data science has a bit of interconnection between these three terms: artificial intelligence, machine learning, and deep learning. So this particular intersection of this data science has the goal of this particular intersection is to make those decisions, but there are lots of things other than those decisions as well. So data science is also is a combination of machine learning and other data analysis. Okay, so that's a simple overview of machine learning. Let's move into a bit of theory. There are mainly three types of machine learning. We have supervised learning, where the model will be learned. So by model, I mean the system, the machine learning or the AI-enabled system will be learned using the label data. By label data, what I mean is you have input and you know what has to be the output for that particular input. And there is this unsupervised learning where you don't have a label data. You have the data you have is unlabeled, where you have lots of data, but you don't know which particular output that input corresponds to. And there is this reinforcement learning. There is a lot of difference between supervised learning, unsupervised learning, and reinforcement learning. So in reinforcement learning, you are making the model to make suitable decisions to maximize the reward. That depends on the environment that model belongs to, and the instance that model belongs to. So in the real world applications, supervised learning is the most used, being obvious because we know that labeled data will give you some of the good powers, because you know what is the input and what's the corresponding output. So you can match them both, and supervised learning is most used. But there are a couple of methods in unsupervised learning in the recent advancements. But however, supervised learning, unsupervised learning is not being able to outperform the supervised learning methods. Yes. Now, what is supervised learning? As I explained previously, supervised learning, you know the input and you are given with the output. You have to train the model such that by seeing those input-output pairs, the model has to match some of other data, some of other input, which we don't know what actually the output is, has to predict what is the output. So as an example, we can see here, so there are three types of flowers. I have categorized A, B, and C. So what you guys need to do is, simply just drop in the chat, what do you think is the category does this flower belongs to? By looking at these three pictures, just drop a chat. What do you think this flower belongs to? A, B, or C? Yeah, there are lots of B. There are lots of B's coming on. Yep. Yes, almost. Yeah, all the answers are, there is an answer which says A, B, and C. Interesting. Yeah, almost all the answers are B. Yeah, I'd say the answer is correct. So the correct answer is B. So this particular flower belongs to the class B. This is a very simple example of supervised learning, where you are given an input and you are given the output, which has to be matched with those input, and the model has to identify this particular which category or which class or even which output does that input belongs to. Interestingly, as humans, since we are visual genius, as I said previously, with the previous knowledge we have in the vision or the previous knowledge we have as a human knowledge, we can identify with 1 or 2 examples which class does this flower belongs to. But that's not the case for machines. We need to feed them lots and lots of data to make them to such a level. So that's the holistic idea of supervised learning. We are giving the supervisory signals. As I said previously, machine learning models receives the input and corresponding desired outputs. So how are you like making the model better? That is nothing but there is the algorithm that is comparing the predicted output. You have the prediction for that particular input, and you have the actual output. You know that prediction and you know the output, and they match with the finding errors. So you know what if the model easily predicts for the previous question, if the model initially predicts A, the model is trained such that the model at the later steps has to predict that particular flower is B. So the goal of supervised learning is to minimize that particular error. As an application side, we know the image classification, the example we saw previously, that is one of the major examples of supervised learning. And also we have this sentiment analysis. So sentiment analysis is something like you have a sentence and you need to categorize whether that sentence corresponds to a positive information or a negative information, or something like it doesn't correspond to any of positive or negative. For example, you see a sentence like I like a cat, so that conveys positive information. So from that, you know, that is a positive signal. And then let's say you have a signal like I don't like a cat, so that conveys a negative information. So a machine learning model has to go through those sentences and easily identify what sentiment does that sentence or the paragraph belongs to. That is called the sentiment analysis. And we have this customer churn prediction. This has been used by a lot. Is nothing but you have to like identify which customers will be stopping from purchasing your product in the upcoming year or upcoming months. So the machine learning model has to forecast their ability of purchasing, and from then onwards, the company will be doing targeted advertisements and personalized recommendations for those particular customers and improve the concept. Is there are lots and lots of real world applications. Hope you can understand this and explore on your own. So there is this unsupervised learning. So in the unsupervised learning, as I said previously, you have lots of data, but you don't have which particular output should that data corresponds to. So that we called unlabeled data set. You have to learn, you have to train the machine learning model without any supervised signal. You don't know which particular output does that input corresponds to. However, the goal of unsupervised learning is to find the structure of the data set. You cannot exactly predict what does that input corresponds to, but rather you can identify what are the structures in the particular data set. We'll see what are the in detail in the next slide. So, or you can find the underlying structure, or even you can group the data. You don't know which particular group that belongs to, but you can simply identify the structure and group them according to their similarities. Even other than that, you can also represent the data in a very compressed format. So like you may have like very high dimensional data, and you can identify the features or the structure, and you have to reduce the dimensions of those data. So some of the examples or the real world applications we have in unsupervised learnings are recommendation systems, which you and I, everyone is encountering these days, like recommendations in Google, recommendations in YouTube, and everywhere in Facebook, everywhere. So those recommendation systems are unsupervised learning methods. So that particular machine learning models identifies or rather segments the customers to which particular group those customers belongs to, and give them their recommendations. Either it can be movies, it can be videos, or it can be advertisements. So based on that particular grouping, the recommendations have been given. And also similar thing is done in customer service personalization. So we don't know which particular output does that customer belongs to, but we know the features, we know the mindset of the customer, and we can match some of the similar customers in the representation. So, and there is also the dimensionality reduction, as I said previously, reducing the dimensions of large scale high dimensional data sets. As an example, we can see clustering. As I said, clustering is one of the major unsupervised learning technique. Here in this particular chart, you can see we don't know which, these are like input points, and we don't know which particular output those inputs are corresponds to. There is no any additional data. We have just these points, but you can see these cluster, this particular set of data points have some similarities. That's why they are represented close together. We call this a representation space or a latent space, whatever. They are represented very close to each other, and these are represented very close to each other, and there is a significant discrepancy between these two clusters. So we can cluster them together and make the decisions for these particular clusters rather than making decisions for individual data points. We can now make decisions for these clusters. So this particular technique has been adapted by lots of the business these days in the that is coming under unsupervised learning. I hope you guys did grasp the basics of unsupervised learning as well. Let's now move on to, okay, we know what unsupervised learning is, and we know what supervised learning is, but how are we going to do that? Like, what are the techniques available these days? So in supervised learning, we have two major tasks. So one is classification. The classification is something I have shown previously, that is the image classification task, or your sentiment analysis. That is also a classification. You have to classify whether that is positive or negative or neutral. And there is this regression. So regression means the output is something like a number. For example, you have to predict the salary of a person, or you have to predict the whatever the age of a person or something like that. So like something like you have to predict a continuous number. In classification, you have to predict a particular category. So we have difference of algorithms, lots of algorithms coming under classification and regression. For example, logistic regression is the very basic algorithm for classification, and decision trees, support vector machines. I won't be going into the details of these algorithms. I'll be sharing the slide with you guys so that you can go through these algorithms and understand what exactly is done behind those algorithms. And I guess you will be having another session, another hands-on session where you can explore what exactly is done by these algorithms as well. So that is supervised learning. In unsupervised learning, we have two major classes, that is clustering. So as I said, clustering is clustering the data points according to the similarity, and dimensionality reduction is reducing the dimension of high dimensional data sets to the low dimensional data sets. Similar to supervised learning, there are lots of algorithms in unsupervised learning as well, where you can explore on your own and try on your own machine learning projects, how you can use these algorithms to make your models perform better. And there is this reinforcement learning. So reinforcement learning is, of course, not much used, like it is used in the real world application, but compared to the supervised learning and unsupervised learning, it's very less used in the real world applications these days. Yes, I was talking about deep learning. Yes, deep learning is a subset of machine learning, which is to replicate the structure and function of the brain. Of course, we cannot like 100% replicate the structure and function of the brain, but the deep learning is the pathway to do so. So we have a term called artificial neural networks, or we call deep neural networks. So using the neural networks, we can use all these. So deep learning also has this supervised learning, unsupervised learning, and reinforcement learning there, because it is a subset of machine learning. It has everything that it has almost all the things that that machine learning possesses. And you can see this particular deep learning is widely used in tasks such as computer vision. So image classification, which I have explained previously, is one of the tasks in computer vision. And the sentiment analysis I was talking previously is one of the tasks in natural language processing. And also you have this what is the difference between the traditional machine learning and deep learning? So what you do is in traditional machine learning, the model is allowed only to train once. You have lots of data, and just by seeing all at once, the model is able to identify the underlying structure of that particular data set and have to make decisions. But in deep learning, the model is allowed to make mistakes. So model can do mistakes at the initial stage, and simple as humans do. We do mistakes at initial stages of our learning process. It can be for the exams, it can be for the general works. We do mistakes. So similar to that, deep learning is allowed to make mistakes and to learn iteratively until it arrives to an optimal conclusion. From that optimal model, you can make decisions. Either it can be image classification or sentiment analysis or object detection, whatever it is. So that's the very simple overview of deep learning. There are like very advanced techniques available in deep learning these days. I highly encourage you to read recent articles and go through recent videos of deep learning and understand what is actually happening in deep learning. So, okay, now we understood the basic concepts of machine learning. What can be done and what is how can be done. But the thing is, if you are studying a machine learning project, if you are to solve a project, you have a problem to solve, how you can approach that? What's the pipeline you can follow to approach? So the initial stage is for business, there is a requirement, and even for the project there is a requirement. So you need to know what is the problem you are going to solve. You need to know what are the scope and what are the expectations at the end of this project. So that is the initial stage of the machine learning project. This might be the same for almost all of the computer science related projects as well. You need to identify what particular problem you're going to solve. On the other hand, once the problem is very well identified, as I said previously, machine learning deals with data. The fuel for machine learning is data. So you need to have data collection. You need to collect data. So there are publicly available data sets which have been open sourced and you can use them freely. And also there are private data sets you have to collect on your own, or your company or your research lab has the private data set, you can use them. So that particular data collection step is there. And then you need to do a data analysis. Without data analysis, you cannot go further. So once you collected data, you need to identify how does this data looks like. For example, if you have images, if you have data of images, what type of images are there? Like what are the categories of images are there? Or what are the objects those are present in those particular images? A simple exploratory data analysis. Or even if you have a tabular data set, or you have a data set of customers with their previous purchases, how those data looks like, what's the pattern you can identify from those data. So that's called the exploratory data analysis. And then comes the data engineering part. This is also one of the important part in the machine learning project pipeline. Means, so the collected data you have collected already might not be clean. It might have been very messy. So there might be some of the data or some of the features which are not available. You might have to clean those data, or you might there might be some nonsense data as well. You have to remove those nonsense data, and then you have to do feature engineering. So by features, what I mean is the corresponding for a particular input, there are features, we call features, that the particular input can be represented by. So there can be multiple features, or we can call them as dimensions as well. So you need to identify which particular feature is more important for this task. For a particular task, you can see there are some features which not even make sense for that particular machine learning project. So you have to get rid of those features. So this particular feature engineering, you have to do that. And then there is feature sampling. So the goal of machine learning is, at least in the supervised learning setting, you have an input data and then you have expected output, actual outputs, and that you can train the model using that. But in the real world, when it comes in the production or when it comes in the form of an application, you won't have an access to like the actual data, actual output. So you will have input and you have to predict the output. So your model should be able to make decisions for the unseen data. That's the important thing here. So you have to sample the data set according to a training set and the validation set. So the training set will have the input and the expected output, and the validation set, you have to validate your machine learning model using those validation set. That's the next step. So, so as I told you previously, there are lots of new terms for you. Please note it down and just do an experiment on your own. Right. So, okay. So the initial hyperparameters are some a specific kind of parameters which we can tune, which we can change to make the model better. So the training set is used when the model is training. So the model is how the model is trained, that is using the previous algorithms we have discussed. It can be supervised learning algorithms or regression algorithms or unsupervised learning algorithms, whatever it is. The model is trained using those training data set and the algorithms we have presented before. So once the model is trained using the parameters and the training data set, you have a trained model. You have a model which is trained with the existing data set, but you are not pretty sure whether you can use that particular trained model in the real world setting. So what you have to do is you have to evaluate that model. You have to validate that model with your validation set and say, yes, this particular model we can use in the production, we can use in the application. So you can use validation set and do the evaluation. So you have the trained model and you can do the model evaluation. If the evaluation you have done is not pretty much in expected rate. So like you expected some, for example, if you talk about accuracy, you expected around 95% accuracy, but your model is performing only like 60 or 70% accuracy. If your model is not reaching the expected output, you can do the hyperparameter tuning. Hyperparameter tuning is nothing but the model has particular parameters. You can tune those parameters and train the model again. So that is the machine learning part of the whole machine learning project cycle. So if you can see, there is a lot more pre-processing is done before the actual machine learning comes under. So you need to be aware for the whole project cycle if you are to make a successful project. Once the model is trained well, you can identify from this model evaluation part, which is the best model, you can use for the application. And then you have the test data. This can be for the business, you have the test data. This can be for the research, you have the test data. Whatever the test data, you can feed it to the best model you have, because that was trained on a validation set. That was evaluated on a validation set. This validation set is not anywhere used for training, which means this model has not previously seen this validation set. So the assumption here is, if a model is performing well in this validation set, that has to perform well in the test data set as well. So you have the test data and you can make the predictions, and from the prediction, you can make the business decisions or the research findings or whatever it is. So that is the holistic machine learning project pipeline we are going through. Okay, we know we have like an overview of how the machine learning projects look like, but what are the tools available to do these things? Like how we can do all of them technically, like, yes. So for that, we have like lots of tools available online. So almost all of the tools I have listed here are open source. You can use them for free. like unlimited. You can make your machine learning models, you can build your machine learning models, you can like train your machine learning models, and like you can make business decisions and research findings. So everything starts with the data storage or the distributed computing part. So you need to have a place where you can store lots of data or do distributed processing, because your local machine might not be enough to do large scale data machine learning projects. So yes, so like we have cloud serving providers such as AWS, Microsoft Azure, and Google GCP. And also PySpark is a distributed computing technology which you can use, and you can use those technologies and do your machine learning projects. On the other hand, you have this exploratory data analysis part. There are lots of beautiful tools. You can use them to visualize your projects and do even statistical processing. R is a programming language where you can do the statistical analysis, and NumPy, Pandas, Seaborn, Matplotlib, and Plotly are like nice visual, like Seaborn, Plotly, and Matplotlib are like nice visualization tools. You can make visual decisions from those data analysis. These are like some of the widely used technologies in the current machine learning community. And also when it comes to feature engineering and machine learning, so by machine learning, I also mean the deep learning part. We have scikit-learn, which have access to almost all the algorithms which have obtained after research findings available. You can use them, just one line of code, you can write the code, and it will produce all the machine, it will does all the machine learning you need to do. And you have TensorFlow, which is from Google, PyTorch, Keras. These are like called deep learning libraries. If you want to do a deep learning project, you are highly encouraged to use one of these particular libraries based on your company requirement or based on your research requirement. You can use whatever the tools and technologies you want. So when it comes to machine learning, specifically deep learning, you have to have a track of what you have done previously, what are the experiments you have done. So in that case, these particular data, these particular technologies such as LabML, which is a very interesting, it's a Sri Lankan product as well, and Neptune.ai, that is also a nice tracking software, and weights and biases. These are like tracking software where you can have a track of what are the experiments you have done previously, what is the workflow you are maintaining for your machine learning projects, so that you can reproduce the previous results as well. So like, let's say if you have done a finding, and you are modifying the model a bit, and your model performs worse, so you have to go back to your previous steps, so that these technologies might be very useful in those tracking, those experiments tracking. Okay, so it's time to do some like look into some interesting threads. So these are like, once you are familiarized with these tools and technologies, you are like, you can go through you can explore your machine learning project on your own, and you can do projects yourself, and you can publish your findings as well. So right, current trends. So in the current trends, I have like 3 links here. I'll show you guys. So generative adversarial networks is something introduced in 2014, but like it's consistently evolving till now. There are like lots of researches and industry works done in generative adversarial networks. We call them GANs. So this is an interesting website that I found. So this person does not exist.com. So the idea is, this person, like the person you are seeing in my screen, this is not a real person. There is no such a person. Every time you reload this page, a new person will come, and this person is not existing in the real world. You cannot see anywhere in the world a person like this. So that's the holistic idea of this generative adversarial networks. So you can generate realistic images. You can artificially generate very realistic images. So every time you refresh, you'll see some new person, where this person is not a person in real life. That's pretty funny, right? But that's true. I mean, whether you believe it or not, that's the reality. And this is GANs are pretty much used everywhere. Like there are lots of applications of GAN, but the disadvantage of GANs is you can do some of the worst things as well. You can do some of the things that are not supposed to be done. One such example is deepfakes. We'll see what deepfakes is. So I'll just switch on this video. It's just 1 minute. You can watch it.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this, simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward, age of information, is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you. Stay woke, bitches.
So interestingly, that particular video you guys have saw is it's not a real one. So that has been fakely created. So this particular deep fake technology has been interestingly very popular these days. That is a very adverse effect of machine learning. So people are not encouraged to be involved in deepfakes. But on the other hand, there is an interesting field called deepfake detection, where you are supposed to identify, the machine learning model is supposed to identify whether a particular video is coming from a fake person or a real person. That's very interesting. And on the other hand, this is one interesting application you all might have heard of, self-driving cars. We'll also see one example of that. So self-driving cars are cars, like, as you know, they drive on their own, like without the aid of the driver. So lots of computer vision in specific, or machine learning in general, techniques are used in deploying such self-driving cars. So in real time, the car should be able to identify the objects in front of the car and like make real-time decisions from those insights. So that's a pretty much emerging technology these days. So if you are interested, you can explore on your own, or you can also even work in the future in a company that is exploring the self-driving cars, like Tesla, or even some of the small startups as well. So yeah, the car is in real time making turns, stopping, or even making signals. So those are done in real time without the aid of drivers, purely using the machine learning technology. So these are some of the, at least some of the very few interesting trends these days, but there are a lot of interesting trends coming across in a monthly basis. Every month there are like lots of new technologies. There are big shot companies like Google, Facebook, and Amazon are working extensively on machine learning. So feel free to just go through, explore on your own, and find out the new technologies in machine learning that interest you the most. So seeing of the career paths in machine learning, I might not be the very experienced person to discuss about this, but just in my perspective, I have categorized machine learning career paths in like two domains. You can pursue a career on industry-based domain, or even you can pursue a career on research-based domain. So as an entry-level jobs, you can choose data scientist, machine learning engineer, data engineer, or data analyst. So this particular job, this particular careers, data scientist or machine learning, whatever it is, so this belongs belongs to the ML project pipeline I have showed you previously. So each and every career pathway is related to some of the simple branches of those ML project workflow. And then from that, the hierarchy goes into senior data scientist. It is not essentially to be a data scientist. It can be a senior machine learning engineer as well. So, and then it goes to principal levels. And also on the other hand, research side, if you are someone interested in the fundamental concepts of machine learning or something, you can create something on your own and do it as a research finding. Research direction is something interesting, something will be interesting for you. So you can do a PhD, you can be a PhD researcher. And then even after doing PhD, you can do research scientist in a company, and then being a senior scientist, lead scientist. And also on the other hand, if you want to pursue academia, you can choose assistant professor, professor, associate professor, and professor. But the interesting thing about machine learning, specifically in machine learning, is lot other areas in computer science are not, the industry and research are not much interconnected in lot other computer science areas. For example, if you see software engineering, there is a significant discrepancy between industry and research. But in machine learning, at least in data science, you can see there is a lot of interconnections between the research field and industry. So there are always industry collaborations with the researchers in machine learning. So like if you are interested, you feel free to explore on your own how the careers are these days done in machine learning, and how you can modify your future goals. So that's a simple understanding of mine towards you guys. And yeah, so we were just going through the stuffs in machine learning, overview, introduction, and then tools and technologies and the current trends and so on. So how you can get started. So how as an undergraduate, how as a freshman or a junior undergraduate, you can get started in machine learning or data science. You are interested in data science, you are interested in machine learning, how can you get started? Yes, the online courses will help you a lot. You can learn from topmost tutors around the world, topmost researchers around the world by these online courses. These three courses are the one I followed personally. The Python for data science in Udemy, and there are a couple of specializations in Coursera. There are also other platforms like Udacity. There is this MIT OpenCourseware, which is a very wonderful platform. You can learn the courses which were taught in Massachusetts Institute of Technology. And there is this Stanford online learning platform that is also very interesting. You can learn the courses which are actually taught in the Stanford University. You can do assignments of them on their own. You can do the projects on their own. That will be very helpful for you to be in parallel with those caliber of students. And there is this EDX. There are also online courses available. Some of these courses are free, and there are at least in Coursera, there is some financial aids you can take to access these courses for free. And there are some of the steps you can follow to take these courses for free. But at least almost all of most of them are paid. So you need to check which suits you the most. And once you are familiarized with the courses are to just familiarize you with the fundamental concepts, fundamental idea of those machine learning topics. So what we talk today is a very simple idea. Like there are lots and lots of others outside this particular session you can explore on your own. So you have to do projects on your own. You can do individual projects. You can select a topic on your own and work on it, or even you can group together and you can select a problem and solve on your own and do some interesting projects as well. That will help you to polish your knowledge that you have learned from those courses. And you can also interestingly you can like publish your findings in like Medium art in the form of a Medium article, or in the form of LinkedIn article, something like that, such that you get a publicity, such that the companies around you know that you are a particular one who is very much proficient in these particular areas. For example, personally, I was doing these three projects when I was in like at least second year in my undergraduate studies. So just to get the idea of how the online courses, how the concepts we have learned is being applied in the real world concepts, real world applications, or in the real world researches going on. So that's the particular idea you have to follow. You need to select a problem. There are lots of online sites you can find interesting projects for you. It can be something a person have already done, or it can be something you found a problem and you are interested in solving that. So whatever it is, just take a project and solve a problem and solve it on your own. And on the other hand, you also have access to lots of competitions. So competitions, the competitive nature always push you forward in, at least in the machine learning domain. So there'll be interesting problems coming in competition. So I had the privilege to take part. This is with my university mates in competitions organized by national competitions such as IntelliHack, which was organized by University of Colombo, and Data Storm, which was organized by University of Moratuwa. And there is this IEEE Video and Image Processing Cup, which was organized in align with one of the international conference and another competition. So like, take part as much as you want in international and national competitions, so that the competitive nature will always push you forward in exploring the new technologies and new trends in machine learning. So for example, the sites such as Kaggle or Driven Data will always have a live competitions going on. You can sign you up there, and then you can choose a problem, choose a competition that interests you and work on it, spend your time. You will be able to see the progress of your own in taking part in those competitions. On the other hand, you also have these well-known international conferences such as CVPR, which is short for Computer Vision and Pattern Recognition, and there is this IEEE International Conference on Image Processing, where those conferences always have a competition track where there'll be like lots of competitions aligned with those conferences. So you'll be competing not only with the national your fellow undergraduates or fellow Sri Lankan people, you'll be also competing with lots of high-class researchers all around the world. So you'll be taking a lot of challenge such that you can move forward in learning the fundamental concepts and even real-world applications as well. So this is one interesting track for you to follow on, taking part in competitions. And on the other hand, you can also make use of the internships you will undergo. As undergraduates, you'll of course undergo internships, which will be mandatory by universities. So make use of those undergraduate internships. If you are interested in machine learning, or specifically or in general artificial intelligence, choose the internship position, internship place which interests you the most. Explore the companies, explore the research groups if you are interested in research, and find out what particular area in machine learning, what particular area in data science I want to pursue, I want to work on. So this internship will always give you a foundation of exploring a lot in the future. So I had the privilege to work as an intern in this Mohammed bin Zayed University of Artificial Intelligence, which is the first AI-based research university in the world. It's based in Abu Dhabi in United Arab Emirates. So I had the privilege to work for 6 months as a research intern, and I published my research findings in British Machine Vision Conference, which is one of the prominent conferences in the field of artificial intelligence. So like that, please make use of the internships you will be following, and keep yourself always updated in the current trends. Keep yourself updated in how you can pursue your career in machine learning. What are the new things? Like specifically in machine learning, in the field of computer science, there are lots and lots of new things coming in the monthly basis. Like a particular machine learning model can be the best one right now, but in 1 month period of time, there will be another model that will outperform the previous model. So there are lots and lots of interesting researches going on. There are lots and lots of interesting applications are developed by machine learning models, machine learning engineers. So feel free to explore on your own and get your interesting machine learning works, machine learning models perform better. So yeah, that's pretty much it. So that will be the end of the presentation, and it's time for you guys to learn some machine learning and get yourself hands-on experience with the machine learning projects. Yes, that's pretty much it. Thank you. So
Thank you.
if you have any questions, please feel free to reach us.
Guys, if you have any questions, drop in the chat.
You can drop in the chat so there was a question, can you give this presentation slide? Yes, we'll be sharing the presentation slide.
And the presentation recording will be uploaded to the YouTube channel. We'll send the link on the chat.
Yeah, so yeah, we will be sharing the presentation. We'll be anyway sharing the presentation slide with you guys. Yeah, are there any other questions? Okay, there was a question. How do we select feature selection algorithm like wrapper embedded for a project? So that depends on the type of data you have. It also comes with the experience you have worked previously. So basically, you need to initially do the data analysis, as I said previously. So the data analysis will give you a grasp of how the data set looks like. And even from the data analysis, you can find what particular features are important in this particular project. So in this particular problem, so you can make use of those data analysis, and I think you can move forward with the feature selection. There is no like cut and write solution for how to do feature selection, but yeah, it comes gradually, I think. Yes.
Thank you, Aya, for the answer. Any more questions?
There's another question. What are the ML trends in Sri Lanka? What about the job availability? So since I am still an undergraduate, so I might not be the best person to answer what about the job availability, but I can comment on what are the ML trends in Sri Lanka. So machine learning has been widely adopted by lots of companies. Like, for example, I can name a few. Like even the AI team is working on lots of interesting machine learning projects. And there is this VeracityAI collaborating with international clients, working with machine learning projects. And also there are like lots of companies transforming themselves toward a data-driven decision-making process. They do their internal stuffs with machine learning, or even they do client-based projects with machine learning. So there are lots of interesting things happening around in Sri Lanka in machine learning.
We'll have a few minutes for some more questions. While we get more questions, we'll share a feedback form. You can fill it while you wait. The form link is in the chat.
So I have shared the link for the presentation slide. You can make use of the presentation, and yeah, just feel free to explore a lot in machine learning.
And you can contact Mr. Afham via LinkedIn and via email. Okay, Mr. Afham, I think that's it for the questions.
Okay.
Okay, let's continue with the session. So, thank you, Mr. Afham, for the brilliant presentation, and it was very insightful. I'm sure all the participants enough knowledge to kickstart their machine learning journey and explore into the machine learning space. So, if you guys have any questions, please leave in the feedback form also, and fill the feedback form. And let's wind up the session. And again, we are very grateful for your presentation and your ideas and thoughts. It was a very insightful one. And I hope all of you will join us with the next session. We'll announce a date, and stay tuned. I think that's about it. Let's wind up the session. Thank you all for joining. And if there are any inconveniences, we are extremely sorry. And have a good night.
Thank you. Good night, everyone.
Okay, thank you.